In this video, we're going to talk about stretching and compressing graphs vertically. So I've done a lot of the work here for the table already, so we'll graph it next. But first, we have f of x equals x squared. So that's what I've drawn here, f of x. This is the parabola that's x squared. Next, we have g of x is 2 times f of x. So the transformation g of x is 2 times f of x. So if I were to write that, this is the same thing as saying 2 times x squared, right? X squared is f of x. Then h of x is 1/2 times f of x, so that's 1/2 x squared. Okay, so then I've completed the table, so this is x squared, okay? This is 2 times whatever was f of x, so 8 to 8. Okay, then half of f of x, so half of 4, half of 1, half of 0, half of 1, half of 4. Okay, so let's go ahead and get to the graphing. Let's graph g of x first. So I have -2 and then 8. I have -1 and 1, or negative 1 and 2 is what I'm going to say, -1 and 2. And 0 and 0, 1 and 2, 2 and 8. Okay, so this is what g of x looks like. So what we can see has happened here is, so if we think about this vertically, it's kind of been pushed, it's just been stretched in the vertical direction. The graph f of x has been stretched in the vertical direction. So we call that a vertical stretch. So g of x is a vertical stretch. And the way you get, the different points on g of x is, what did we do? We basically multiplied 2 by all of the y coordinates, right? So this coordinate here used to be, so it was 2, 4, and then it became, for g of x, when it got stretched, it was 2, 8. Okay, so the y coordinate got multiplied by 2. So that's the vertical stretch. Now let's talk about h of x. So let's go ahead and graph h of x first. So when x is 2, y is 2, and then when x is -1, it's 1/2, then 0, 1/2, and then 2. Okay, so this is h of x. So h of x, you can see it's been compressed. Okay, so it's been compressed in the vertical direction. Pushed down, you could think of. Okay, so stretched mean pushed up, and then pushed down would be to be compressed. So h of x is it's called the vertical compression, or vertically compressed. And to get points on h of x, what did we do? Basically, that same 2, 4 then became 2, 2. So basically, we multiplied the 1/2 by all the y coordinates. So the next slide, I'll solidify this with a rule, and then we'll do a few more examples. Okay, so here's that rule. So where a is some sort of constant, and then a times f of x is a vertical stretch, the absolute value of a is greater than 1. Okay? In other words, if a is, not a fraction. Okay? Or it's a vertical compression if the absolute value of a is less than 1, meaning it is a fraction. So this is the case in the previous slide where, so it was a stretch when a was 2, right? It was 2 times f of x. And it was a compression when a was 1/2. It was 1/2 times f of x. Okay? So the way you do vertical stretches and compressions is you just multiply the y coordinate by a. That's it. Alright, let's go ahead and do this example here. So what is this? Is this a stretch or a compression? Well, 3 is not a fraction, right? So it's a stretch. So this is a vertical stretch. You know, we say vertical stretch by factor of 3. Okay, that's the way we would write that. And then if I were to draw this, this is what f of x looks like. Okay. And then g of x, so it's a vertical stretch by a factor of 3. Okay, so, you know, I'm still going to have this 0.00 here, where it used to be, so this point here is 1, 1. Where it used to be 1, 1, now it's going to be 1 and then 3 times 1. Okay, so 1 and 3. 1, 2, 3. So now it's going to be up here. So g of x now is going to look something like this. So it's a vertical stretch. You know, you're seeing the stretch happen, the stretch by a factor of 3. So this is g of x. Okay, let's do the next example. So first thing I want to notice is that this is not just a straightforward vertical compression, right? There's more going on here. So first thing I'm going to do is I'm going to rewrite this with regards to f of x. So g of x, and this one, is the same thing as 1 minus 1/2. Well, f of x is the square root of x, so 1/2 times the square root of x. So I'm going to write f of x like that. And then I'm going to rewrite it one more time. So I have this in the back. Oh, not plus d, but plus 1. Okay. All right. So now I have, all right, 1/2, negative 1/2 f of x. That's in the front, and then plus 1. So now so there's more going on. There's actually, there's 3 things happening here. The first thing that you might see is, so starting on the left, and then we'll move right. So you see that negative sign out front. In the previous video, we talked about reflections, and we said if the negative sign is out front like this, then it's a vertical reflection over the, or it's a reflection over the x-axis. So let's go ahead and write that. Reflection over x-axis. And the next thing is this 1/2 times f of x. Now that looks like what we have up here. So 1/2 times f of x. Now the absolute value of a is less than 1 because it's 1/2, right? So that's a vertical compression. So we have a vertical compression by a factor of 1/2. Okay, and then the last thing that we see is that we have a plus 1 out front, or out back, right? So we have a plus 1. Now that was in one of the first videos about transformations, and when we were talking about horizontal and vertical transformations. And we said that if you have something that looks like this, I'm going to write it up here, if you have f of x plus d, then that is a vertical transformation where you go up by d if d, or down by d if d is negative. So in this case d is positive, so we're going to do a vertical shift up by 1. Okay, so now if you were to plot this, let's go ahead and do this up here. This is what the original graph looks like. Okay, that's f of x. Okay, now the order that you do these transformations actually does matter, and that's why I rewrote it like this. In the next video, or the video after that, I'm actually going to formalize this and solidify this idea of doing multiple transformations in a row like this. But first let's do the reflection over the x-axis. So let's think about that. That would be like something looking like this. Okay, I'm drawing it in dotted lines because it's not done yet. And then a vertical compression by a factor of 1/2. Right, so where the point used to be 1, 1, now it's going to be well, it's reflected, so instead of being down here at -1, it's going to be at 1/2. So I'm going to have something that looks, actually let me draw it in blue, so the next step is in blue. So something like that, so it's going to be compressed. Okay, and then a vertical shift up by 1, okay? So this point that is now, so I'm thinking about this point that's, -1/2. Oops, I wrote that in the wrong direction. X comes first. So 1 -1/2. Okay, so this point that I just talked about, 1 -1/2, now it's going to be shifted up by 1. So up by 1 means that, the y-axis, the y-coordinate is going to go up. So so 1/2, -1/2 plus 1 is 1/2. So it's going to go to being 1 1/2. So that's basically like here. And then instead of starting at 0, since it's being shifted up 1, it's going to be starting up here. And so basic shape of the graph will look like this.